Good evening and welcome to Mrs. Spencer's Math Lab. Glad to have you returning, and if you are new, I'm glad to have you with us this week. I hope that you are ready for work, because this is definitely not a lecture. We work together. Today we are going to be exploring exponents. So get ready, get your pencil, your paper, and I think I'm going to allow you to use your calculators on some things today. So bring that with you as well. And of course, bring your mind, open mind, ready to work and ready to say that math is not hard, it's easy. And that's one thing I want you to learn as we work together. That it's just a matter of understanding what you're doing, understanding the concept and developing the skills. So let's get ready to explore exponents. Before I start, I'd like for you to turn your sound up, hit those little arrows so that the screen is larger and you can see my board better. And we're ready to go. So let's talk about exponents. What are exponents? All right, exponents. First of all, how does it look? It's a small number, and I don't mean in value, but it's written small. Written on the upper right side of a number or a variable. So that's where it's located. So we need to know what it looks like. Then, what does the exponent do? What does it tell us? It tells us how many times a number or a variable is a factor. And what do I mean by is a factor? It's being multiplied by itself. Okay? So when we look for it, we know where it's located, and now we know what it tells us. So again, it's located in the upper right side of a letter or a variable, let's say, or a number, and it tells us how many times that variable or number is being multiplied by itself. In other words, how many times that variable or number is a factor. So let's get to work on some exponents. All right, so let's start. All right, I'm going to start with the number, and this is called the base number. And that's going to be very important because what we do today, each time we work, the base will be the same. So this is part 1 today. Next week, we will work on part 2. And part 2 will be with some variables other than with different bases. All right, we have the base is 2. And we'll put this little 1 up there. That little 1 is the exponent. And it says 2 to the first power. That's how we read it. 2 to the first power. So you say that to yourself as well. 2 to the first power. So that tells us 2 is a factor only once. So that's equivalent then to itself. Any number raised to the first power is equal to itself. So if it was 100 raised to the first power, it would equal 100. If it's 60 to the first power, it would be 60. If it's x raised to the first power, it would be x, whatever it is. So we're going to work with numbers first, and then we'll go to variables. All right, 2 to the second power. All right, so that means that I'm going to have 2 2's. 2 times 2. The little dot is the time sign. All right, so what is the value of 2 to the second power? And of course, we know 2 times 2 is 4. 2 to the third power is what? 3 2's, 2, 2, 2. Product of 3. And please don't tell me 6. I don't know why. This is the one that everybody gets wrong. 2 to the third power is not 6. So let me get that right now if you started to write that. Because it means 2 times 2, which is 4. And 4 times 2 is 8. We're not adding 2's. We are multiplying. So what is 2 to the 4th power? Okay, I'm going to stop a moment and let you do that one. 2 to the 4th power. Remember, the exponent tells you how many times that number is a factor. So 2 is a factor 4 times. It's being multiplied by itself 4 times. And what did you get? All right, so right now we're going to write it out. 1, 2, 3, 4, and what did you get? You should have gotten 16. All right. So what would 2 to the 5th power be? 2 to the 5th power. You should now be able to tell me that almost without working it out, since we've already got 2 to the 4th power. So it would be one more 2, and that would be 2, 1, 2, 3, 4, 5. All right, and so that's equals what? 2 to the 5th power is 32. All right, so I want you to find 2 to the 7th power. I'm going to skip one. See if you can do that for me. 2 to the 7th power. All right, and so I'm going to wait a moment. Remember, the exponent is this little number written to the right of the base number, and the base number here is 2. And it tells us how many times that number is being multiplied by itself. Other words, how many times that number is a factor. All right. So 2 to the 7th power, what did you get? All right. If you expand it, you should have written out how many 2's? 7. And when you multiply, what is the product? All right, did you get 128? Okay, good. All right, so backing up again, the exponent is this little number. It's written up on the right of the base number. The base number we're using here right now is 2. All right, let's change our base number. And I'm going to put you to work for a moment. Let me see, I better do this. Okay, so let's say 3 to the 4th. I'm going to skip around a little bit. 3 to the 4th power. 10 to the 3rd power. We've done 2 to the 3rd power. Okay, 6 to the 2nd power. And I didn't give you long ones because 5 to the 6th power. Okay, let's see if you can evaluate each of those. Tell me what each one of these is equal to. 3 to the 4th power, 10 to the 3rd power, 6 to the 2nd power, and 5 to the 6th power. Okay, I'll start the first one. We have 4 3's. Times 3 times 3 times 3 times 3. And what did you get? Now that doesn't mean 4 times 3. Let's not confuse that, because this is an exponent, not a multiplier, not another factor. It is an exponent. So 3 and 3 is 9 times 9 is what? 81. All right, 10 to the 3rd. 10s are very easy. Very easy. So right away, I can look at the 10s and see what they would be. All right, but I'll write it out this time. 10 times 10 times 10. And so that's 1 and 3 zeros. 1,000. Did you get that? Sure you did. 6 to the 2nd power, that's easy. 6 times 6, and that's 36. All right, now I'm not going to do that one with you right now. I'm going to see if you can do that. 5 to the 6th power. And we need to know how to read it. So I'm reading them to you each time so that you can know how to read it. 5 to the 6th power. That means 5 is raised to the 6th power. That means 5 is a factor 6 times. 5 is being multiplied by itself 6 times. Okay. Okay. So I might let you use your calculator for that one, if you'd like. But it's always best to use this brain as much as you can. You'll find that this brain is pretty good if you learn to use it. This calculator works well. All right, so we have how many 5 factors? 6, 2, 3, 4, 5, 6. And what do we get? Okay, what do we get? I'm waiting for some answers to come up on the screen for me. What did you get? I'm going to check my answer, make sure I'm right. Where's my calculator? All right. I had to the 4th, but I did write it this way, so we'll go ahead and do this. All right. I know that this is, and you can break it up, 25. And I know that this is 25. And I know that this is 25. Okay? So 25 times, that's going to be what? 625. 625. And then multiply that by 25. All right, what did you get? Do I see any answers coming on the screen? You see any? I'm waiting for you. Answers on the screen. All right, 625 times 25. What did you get? Let's see. I'm trying to get this cleared out. 25 times 625. All right, you should have gotten 15,625. Okay. All right. So, this was just a little exercise to get you used to seeing what it means each time we see a number raised to a power. All right, now let's do some variables. Let's do some variables. Okay, so now you should be able to answer this very quickly for me. Now that you know what the exponent tells you, how many times the variable is being multiplied by itself. So x to the 1st power. Okay, of course we said that's going to be x because it's only one. All right, x to the 2nd power is what? X times x. All right. X to the 3rd power is x times x times x. Now I'm going to reverse it. And I'm going to write x times x times x times x times x. And I want you to write it in the form of with the exponents. Okay. So I hope you wrote x, which is the base. 1, 2, 3, 4, 5. The exponent is 5. How easy is that? All right, so now we basically understand what exponents are. And let's see how we can do some operations with them. All right. Let's see how we can do some operations with them. For example, suppose I had x squared times x cubed. X to the third power is usually said x cubed, and x to the second power, it says x squared. But it would be all right if you said x to the third power times x second power times x to the third power. Okay, what do you think that would be? So let's expand it. I'm going to work over here. Okay, x to the second power is x times x. Okay, and x to the third power is x times x times x. Right. So, what then is the answer to x squared times x cubed? Let's count it. 1, 2, 3, 4, 5. So it's x to the fifth power. How easy is that? X to the fifth power. Okay, let's try a second one. Let's do this one. 2 to the fourth to the third power times 2 to the second power. So we could see, I just reversed those. See what you get for that. So let's expand it. 2 to the third power is 1, 2, 3. Okay. And 2 to the second power is 1, 2. Okay. Okay, so we get 2 to the what? 2 to the fifth power. Okay, I'm hoping you are watching. Always watch for patterns, because I never teach straight from a rule. But after a while, after we do enough, you should be able to see what happens when we work a certain way. So let's keep looking. Let's not jump to conclusions. Let's do another one. All right, let's do d to the fourth power times d to the third power. All right. Some of you have already written your answers, because I bet you already see the pattern that has happened. All right, d to the fourth power is 1, 2, 3, 4. Okay, d to the third power is 1, 2, 3. Okay, and let's just see. 1, 2, 3, 4, 5, 6, 7. So that's d to the seventh power. How many of you are seeing something, a pattern here? I never teach from a rule. I teach to a rule. So as I work with you, you're looking for things that continue to happen. And you're questioning, is this how we could do it? So are we going to always have to do this, expanding it? It's all right if you're still expanding. But I'm sure some of you see a pattern when you're multiplying. Now notice that the bases are the same. If I start with 2, I'm working with 2's. If I start with x's, I'm working with x's. This week. Next week, I will do other variables as well. All right, let's do a to the 4th times a to the 8th. All right, what do you get? How many of you were able to write your answers already? All right, so this is 4. 1, 2, 3, 4. And this is 8. 1, 2, 3, 4, 5, 6, 7, 8. So we count them and we get 8 to the what? 8 to the 12th power. How many of you were able to write that because you already see what's happening with these exponents? Yeah, excuse me. A to the 12th power. My helper here is making sure I don't make mistakes, and I appreciate that. All right, because talking and writing, sometimes you're saying one thing and writing another. All right, so what do you notice when we're multiplying? Now, notice the base is the same. I emphasize that because when we do part 2 next week, we are going to use different bases, and we are going to have to remember that we only, these work when the bases are the same. So what do you notice we could do then, instead of writing out all of this expansion? And again, do that as long as you need to until you're ready to do a shorter way. But if you have watched it, you will notice that what we did was simply add the exponents. That's what we're doing every time. 4 plus 8 is 12. And the base is A. All right, so let's do a few more just for fun. X to the 2nd times x to the 8th. All right. Y to the 5th times y. All right. B to the 3rd times b to the 5th. Okay. And 10 to the 3rd times 10 to the 3rd. Okay, I'm going to give you a moment to work with those. Some of you may still be working with expansion, and some of you may just be adding the exponents. And after a while, all of you will be just adding the exponents. But as long as you need to do the expansion, do it. The thing I want you to do is to correctly do the problems. All right? So, the base here is x. So we write x. We add the exponents. 2 plus 8 is 10. All right, the base here is y. We add the exponents. 5 plus 1. We don't usually write ones for exponents. I did that first to show you what it meant. But if it was 0, it would be a different thing. And I'm going to talk about 0 and negative exponents another time. But when there is no exponents, if it's there, it means to the 1st power. So 5 plus 1 is 6. Y to the 6th power. B is the base. And we add 3 plus 5 is 8. All right. And here, 10 is the base. 3 plus 3 is 6. Now, usually when we do numbers, they expect you to expand that and give the numerical answer. What is the numerical answer here? 10 to the 6th power. What is the numerical answer without the exponent? And I'm not talking about the expansion either. just a number that represents 10 to the 6th power. Okay, again, tens are easy. So it's 1 and 6 zeros. 1, 2, 3, 4, 5, 6. So that's what? 1 million. How easy is that? All right, so what have we done so far? We've identified what exponents are, what they look like, where they're located. We know it's the upper right-hand side of a number. They're just small in size, not in value. Okay, and we know that the exponent tells us how many times that number is being multiplied by itself. Then, when we multiply two expressions that have the same base, then we merely, to make a shortcut, we can just add the exponents, keep the same base. How easy is that? All right, so let's see what else we can do with these exponents. So we learned how to multiply. So let's see what happens when we divide. All right, let's do 2 to the 4th power divided by 2 to the 2nd power. Okay, remember this expresses division. Don't say 2 over, because over is not and we say that so often, and we forget that we are really dividing here. This means 2 to the 4th power divided by 2 to the 2nd power. This is a dividing line, and most of us think that it just separates the numerator from the denominator. No, it expresses division of the numerator divided by the denominator. So this really means 2 to the 4th power divided by 2 to the 2nd power. Let's expand it. 2, 1, 2, 3, 4. Okay, and this is 1, 2. All right, this is expansion that we'd already learned to do. And I noticed something here, and this is something I try to get students to do with fractions, because I know one day they're going to get to this kind of thing, and they need to do that, because otherwise it's going to make some problems very difficult. So what we're going to do is simplify. We're going to do some what we call cancellation. Cancellation is not destroying something, just taking it out. It's actually dividing. And when we say that, and we say cancellation, people think well, it's just out now. So what we do, we see people do this. But that doesn't mean there's a 0 here now, because we've said 2 divided by 2, 2 divided by 2. So it's a 1. Now, we don't write all those 1s, but I'm going to write it today because I want to emphasize that it doesn't cancel out to 0. And sometimes when we get to further problems in algebra, if we don't have this understanding, then we have a problem. All right, so this can cancel with this one because we divide both those by 2. Now, we don't have anything else at the bottom to cancel with. So you can cancel any number in the numerator with any number in the denominator that is the same factor or has a common factor. So we'll get to that a little later. So what do we have left? We have then 2 to the 2nd power, because there's 2 left. Okay, I'm going to leave that up there. I want you to look at it a moment while we do another. Let's do 3 to the 5th power divided by 3 to the 4th power. All right, I'm going to work now with the cancellation process. So I'm going to expand it. And I remember, I don't teach rules, but when you see what's happening, then I allow you to do a shortcut. but I don't teach shortcuts because I want you to understand why it is happening. So you have 5 3s, the product of 5 3s. Okay? And the product of 4 3s. Okay, let's do our cancellation. 3 divided by 3, these 3's cancel out, and I don't even like to say cancel out. These 3's cancel, they cancel, okay, they cancel, and they cancel. So what is the answer? Just plain 3. 3 to the first power. How many of you are beginning to see something? Okay, let's do a different type. X to the 7th power divided by X to the 9th power. All right, go ahead and expand that and let's see what you get. All right, I have 7 X's. 3, 1, 1. This is getting 1, 2, 3. Let's see if I can get a better pen. 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, and this is times. Put your little time signs in the middle. Okay, and X to the 9th. It's X, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so we can cancel X's. It has to have a match. Okay, now, okay, so what is at the top? Remember, I said all these are what? Understood to be ones. So the answer then is going to be 1 at the numerator and over X squared. Okay? 1 over X squared. And that's why I wanted you to be sure that you know when we cancel these, they are not coming out to be 0. They're ones because we're actually dividing X's by X's all the way over. But because we have the like factors, we can just scratch them out, match them, numerator with the denominator. All right. So, does anyone already see what is happening here? Actually, what could I have done to do this without expanding? All right, I'm going to do a couple more, and if you have seen what to do without expanding, then I'll allow you to do that at this time. I'll allow you to do that at this time. All right, I want you to do y to the 6th power divided by y to the 8th power. And c to the 2nd power, 12th power, I'm going to make it larger, divided by c to the 4th power. All right? And I'm just going to put those two up at this time. So, what do you notice? How many of you could do these without expanding? Okay? So this time I'm going to do this without expanding, and I'm still not giving you a rule because I do not teach rules. Rules come when you understand something. You say, oh, I see that this happens. All right, so looking at y to the 6th and y to the 8th. All right, let me get another color so that you'll See what I'm doing? I know that these y's in the top, all six of those, and that's the 1, will cancel out 6 of these, and there'll be 2 left. How easy is that? If you had them all stretched out, that is what you would find. So the result here is what? 1 divided by y to the 2nd power. Okay? All right, let's see what you did here. Okay, taking that same idea, I know that I have 4 here. So I'm going to cancel all 4 of them out, and that's a 1. And I can cancel out with 4 of these, and 4 of these would leave me 8. Now I'm not, and here notice I cancel out the C as well. Why? Because I have all the 4 C's. Here the C's still have some left. So I have then what? The answer is C to the 8th over 1. And we don't write that. We just don't write divided by 1. That's understood. All right. So how many saw something? Now again, as long as you need to use one of these methods that I have shown you, use it. But if you were looking at it and really trying to see what you could do to make that easier, you would find that you were really merely subtracting the exponents. And notice I have the arrow because you subtract down, not up. You subtract down. So you subtract the numerator minus the denominator. The numerator exponent minus the denominator. So let's see what we would have gotten here. So we'd have 6 minus 8. And that equals negative 2. Now, next week when we get to negative exponents, you understand that that's why this is in the bottom, not at the top. And you will understand that at next week. But this one is easy to see that we have 12 minus 4 equals 8. 12 minus 4 equals 8. Okay, and of course that's that. All right, let me do one more because there's another type that's not up here, and I want to be sure that you are clear with this. Again, use the method that you do best until you understand it better. All right, let's do C to the 8th, C to the 2nd. Let's see what you get. So, what is it? C to the what? And of course, remember, when the larger number is in the numerator, then the extra C's or extra bases that are going to be up there. When the larger number is in the denominator, and I'm going to do this just the opposite to show you. Okay, so let's clarify this. C to the 8th is, that means you have these 2 cancel out and these 6 up here. So the larger number, the leftover ones are in the numerator. C to the 6th. All right, when you subtract here, the larger number, the C cancels out 2 of these, and you have 6, but they're in the denominator. So wherever the excess ones are, that's where the value belongs. So this one then would be 1. Remember, when we cancel something all the way out, it doesn't mean it's 0, it means it's 1 over C to the 6th power. Notice the difference in these two. Always subtract down. The numerator, exponent in the numerator, minus the exponent in the denominator. How easy is that? So those of you who have already seen that you can subtract, then do that. Those of you who need to expand, that is to write them all out, all the C's out, the 6 C's out, and how many of it, write them. And those of you who can do this method, I've shown you 3 ways to do this. And either way is correct. Those who just merely want to subtract the exponents, do that. But all of us should come out with the same results. All right, and then we have one more concept that I want to get to today. And now, what do I expect you to do? I expect you to practice this. One way you can practice is copy the problems that we have done together. Put that paper aside and see if you can do them without looking. Another way is to go online and find some examples of the same type of problems. But you must practice. Practice makes perfect in any situation that you have. If it's a skill, you must practice. All right, now suppose I had 2 to the 2nd power. Okay. How do we read that? We have 2 to the 2nd power, and let me blacken it so my pens want to give out on me today for some reason. All right, we have 2 to the 2nd power, that's raised to the 3rd power. So this whole thing in here is raised to the 3rd power. So what is raised to the 3rd power? 2 to the 2nd power. So what does that mean? That means we have 3 of those. So 2 to the 2nd power and 2 to the 2nd power and 2 to the 2nd power. Okay. So what is the result then? All right, if you got to write them all out, do that. If you remember that what we do with exponents when we're multiplying, good. If you don't, just expand it. That means 1, 2, 3, 4, 5, 6. So that's going to be 2 to the 6th power. How much is 2 to the 6th power? Quickly. All right, you should find that that's 64 if you were asked to do it. All right, so, okay, let's do another. I'm going to do it with 2's first. I'm going to do it with numbers first. 3 to the 4th power raised to the 2nd power. Keep them small at first so that you can get the concept. So that means what's inside the parenthesis has to be raised to this power. So that's 3 to the 4th times 3 to the 4th. Okay. So 3 to the 4th times 3 to the 4th. And we've already learned how to do this. So that's 1, 2, 3, 4, 5, 6, 7, what? 8. 3 to the 8th power. All right, 4 plus 4 is what? 8. All right, don't get confused now with the operations. How many of you are beginning to see something? Because it doesn't take you long to see some patterns in this mathematics. That's why it's not hard. It's not hard. Let's do some variables and see how we'd work with them. All right, 2 to the 2nd power raised to the 3rd power means that I write this 3 times and simplify. 3 to the 4th power raised to the 2nd power, I write it twice because this exponent tells me I write what's in here twice. And then I go ahead and simplify that. All right, so now I'm going to use some variables. So let's start out with our favorite variable. We x all the time. X squared raised to the 5th power. All right, let's do y cubed, y to the 3rd power, in other words, raised to the 4th power. And let's do c to the 2nd power, raised to the 5th power. Well, no, I've already got 2 and 5, so let me use some other exponents. All right, let's use 5 and 6, just to make it interesting. All right, so what's inside of the parenthesis is operating with this exponent on the outside of the parenthesis. And that tells me how many times I have to multiply this. And then this exponent tells me how many times this is. So we're putting it all together now. So what do we have? All right, we have x squared, x squared, x squared, x squared, x squared. All right, so that's 2, 4, 6, 8, 10. So that's equal x to the 10th. How many see something already? All right, so if you see something, write that answer right away. Y to the 3rd power raised to the 4th power. Means I'm going to have 4 of them. Y cubed times y cubed times y cubed. I said y and wrote x. Y cubed times y cubed. All right, so we got 4 of them. So we know that's, okay, what did you get? Did you get y to the 12th? Okay, so how many of you see something? Now, I'm not going to expand this one because this is a longer one. But if you see something, write this answer for me. If you see the pattern, write this answer for me. All right. So did you write c to the what? 30th power? Because what are we doing in this situation? When we have an expression like this, a power raised to a power, what are we doing with those exponents? Actually, all we're doing is what? Multiplying them. How many of you saw that? If you saw that, give yourself a pat on the back. Because going back, 2 times 5 is what? 10. So that's x to the 10th. 3 times 4 is 12. So that's y to the 12th. 5 times 6 is 30. So that's c to the 30th power. All right, so now we have done 3 types of problems with these exponents today. First, we learned to multiply them if they have the same base. So I'm going to put one of those up. All right. A to the 4th power times a to the 3rd power. All right, we now learn how to divide them if they have the same base. A to the 8th power divided by a to the 4th power. All right, and then we learn how to raise a power to another power. So we had like a to the 6th power raised to the 2nd power. Those are 3 types of problems that we have learned to do with exponents today. All right, when we have this type, the bases are the same, we merely add the exponents. 4 plus 3 is what? 7. A to the 7th. 1, 2, 3, 4, 5, 6, 7. We have to expand it. When we're dividing, we divide down, and I do this arrow because students have a tendency to want to turn it around if the larger number is at the bottom. No, the division is always from the top to the bottom. Okay, 8 divided by 4. All right, so what is the answer? We have the excess 4 there, so it would be a to the 4th. This cancels out, and these 4 up here. All right, let me do this. Bring back to your remembrance. This one cancels all the way out, and that's a 1. And 4 of these match to 4 of those, so there are 4 left. Remember that. All right, and the last type was a to the 6th power raised to the 2nd power. So that's a to the 6th times a to the 6th, and we back up here with this, right? All right, so this is the same as 6 times 2, which is what? A to the 12th power. All right, so how easy this is. It's not difficult. Let's think about it. These are the 3 types that you have had today. And next week, we're going to work when we have different bases, and I want to explain to you what happens when the exponent is 0. And also, if we have time, we can work with some negative exponents. I hope you have understood today what we have done, and I hope that you are ready to do some practice. And as I said, you have these problems that we have worked out together, and all you need to do is copy some of those, see if you can do them, go back over your notes. Remember, when we're multiplying 2 powers with the same base, we merely add the exponents. If you can't do that yet, we can write out all the A's and cancel them. All right? And count them. All right, here we're dividing, and you can write out all the A's. It would be 8 on top and 4 at the bottom, and 4 of them would cancel out on both the top and the bottom. In fact, all of those at the bottom would cancel out, and there would be just 4 left at the top. All right, and a to the 6th power times this. This is the type. Then you could put 6 of those out, and then work it from there. If you need to expand, and when I say expand, write out all the variables and count them, do that. If you have already understood, hey, I can do that by just multiplying, adding, or subtracting, then do that. Wherever you find yourself today, whatever level you are on. So even an elementary school student can do this. Maybe not on the same level as one of you on a higher grade. Again, we're exploring exponents. And exponents are the small numbers written to the right of a base number or a base variable that tells how many times that variable or that number is being multiplied by itself. Again, thanks for being with me today, and I'll see you next week for part 2 of exploring exponents.